Hello and welcome to this building domain session as part of the buildingSMART International Standards Summit Valencia 2024. Thank you for joining. My name is Sheila Karailam and I will be your moderator today. Today's session is titled Unlocking Building Energy Efficiency. This session is scheduled to last 90 minutes, including time for questions at the end. The session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to the speakers, I would like to remind you that this is a hybrid event. For those online, your microphones will remain muted for the duration of this session. If you wish to make a comment or ask a question, please use the chat box in the control panel. For those of you in the room here today, kindly keep the background noise to a minimum. And if you wish to make a comment or ask a question, please raise your hand and we will bring a microphone over to you. I would also like to bring to your attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent. And standards that are developed do not favour any particular provider and are open, non-binding and accessible to all. Please take note of our antitrust code of conduct. And on that note, I would like to hand over to David.
Thanks, Sheila. Will you go back to the other slide?
Sure.
I'll introduce everybody really quickly and then we'll get going. Oh, there we go. All right. Okay, so we're going to do a little unlocking building energy efficiency today. With me today, we have Roef, who co-chairs the building domain. With me, I'm David Ivey, Senior Design Technology Manager at HOK. We have Jörg Ziolkowski, who's a member of the buildingSMART Germany board, which I met this morning. So welcome, Jörg. Jönsson, Mirbek, Bekboliev, and Nisbet, who's sort of famous for the regulatory room, but is joining us today to play the role of building authority. So everybody's got a role to play. The client will be Rob. Let's see, the architect is Jörg. The LCA expert is Jan Anders. The building energy performance consultant is Mirbek, and he'll be kind of driving the presentation today. And then again, if you have questions at any point for any of the members, let me know and I'll run over with the mic. So, all right, Mirbek, you want to take it away?
Yeah. I will use this mic, right? So, good morning, everyone. Thank you, David, and thank you for all presenters today joining us. And we have, is it now visible? We have prepared the agenda.
Do we want people to interject questions at any time?
After the
main
presenter.
presentation? Okay.
Okay. Each presenter has a chance to present until the end, and then it will be like a section. After the section, you may ask your questions. That's the organizational stuff. General questions regarding the whole session we'll keep at the end, but in between, if you have some questions for all presenters, then you can simply ask and raise your hand. So we, like David already mentioned, we have roles, and we decided to bring this idea from the sustainability strategy group to try some examples. And in the past, we published an IDM or technical report for BIM and BAM, building energy modeling. And with that, like, why not to bring that into not on a paper, but also on a machine-readable way into the model, at least to check the quality of all models before we'll do any kind of simulations. As you can see, we will go through some steps regarding requirements, and those requirements coming from each party that we identified as a role. And we will start slowly with the introduction, why we wanted to have this, and why we want to achieve interoperability and in general the quality of information that we will be delivering. Following that, Rob will describe his dream home, summer home, which is actually, as a surprise, we'll see now. We will have requirements from Nick regarding activities also from the regulatory room that may be interesting to experience here. We have requirements from LCE regarding global warming potential. And of course, BIM and BAM requirements itself as ideas, and we combined them into one single ideas, not to not to separate them. We have a small house that we will test thanks to our architect, Jörg. And of course, we will try the live demo then. So this is a short overview. Now we'll explain what was the idea behind why we need to do that. The workflow itself, we said we need to have clear requirements. And the client requirements, of course, are the most important, first of all. If you have your requirements clearly defined, and they should be as much as precise as it could be, so that then you will bring that into IDS. But IDS is just a medium that you require. The most important is what you expect should be written, and that's what we're trying here. And now, as an objective, we will first of all try the main goal of this, not to be 100% currently ideal. It's not. It's still a work in progress. The main objective to show that open BIM workflow in general works. That's what we require. We will try and run, and we'll see that everything could be attached to the PCF. It could be tested with IDS. BSTD will be our service to use and to define some requirements. To help to define requirements, sorry. And of course, IFC will be tested later on at the simulation for energy performance. So now I'll give it to our client. Client, please explain your dream home.
Yeah, thank you very much. Maybe it's good that
You can close it up.
Oh, yeah. Thank you very much, Mirbek. Yeah, maybe you can put the next slide on. So yeah, they asked me, well, to describe my ideal summer cottage. So yeah, that was, I find a very nice spot. It was a little bit south of Valencia. It was at the waterside because I wanted to do fishing. I want to have it small, not too big, with a separate bedroom, a double shower. I love to cook, so it needed to have some good kitchen, a wine cooler, and those kind of things. But I was thinking about it need to be energy neutral. I want to have it efficiently cooled. So, but I have no idea about, you know, architecture or whatever. So I described it to Jörg. So I'm really, yeah, I'm curious what you what you designed, and yeah, I said, well, preferable a pirate flag somewhere. Yeah, that really is my dream. You know, I want to have a little cottage somewhere with a pirate flag. Yeah, I love to sail, and yeah, what was it? Oh yeah, a jacuzzi, of course. And did you manage that? Oh, not yet. Okay, I will see it later. Large windows facing south over the sea, of course. And yeah, I think, well, I'm curious now, Jörg. Will you? Can you show it already, or? Oh, okay.
Yeah, Asian. Of course, there is a space on the. If you haven't seen the technical report BIM and BAM, there is a real the process map that shows how you what would be ideal, the most optimal way to go through the project. Of course, the client requirements, later on you will see that process map I will showing. There we capture client requirements, and the client, of course, will be consulting consultants of a related discipline for sustainability, for regulatory, maybe for other structural engineering and so on. But there, if you see, a rough understanding what does a climate look like. So we need to get that requirement. So that was a little bit adapted client requirements now after consultation. We said like, okay, we need this and that, as you can see, with additional notes and recommendation. And of course, that will also be part of IDS and ended in the IDS as a requirement. So I will now quickly mention some of them are indeed part of IDS, some are not specified. We used the previous version, by the way, of IDS that is currently under final revision and final review. Sorry, not revision. Okay, now those requirements, as you can see, we have stated and in a human readable way. Now we will go through next requirements. And Nick, could you please provide your building authority requirements?
Yeah, I didn't bring my suit to Valencia, but I am a building official. And my job is to make life difficult for this person and this person and this person and this person. But luckily the rules have been written down, and we're going to see some magic where we can see that requirements and rules can be automated. And so as we have a better information base for the industry, we can do more and more interesting things. So, I want to show the role of regulation. I want to show the nature of some regulatory requirements, and I'm going to show some results of automatic checking. And I think the message is that wherever the requirements come from, they can be brought into a process. So let's have the next slide. Oh, yes. Okay. Not the order I expected. Yeah, okay, right. One of the things you can do with requirements, real requirements, like a building inspector enforces, is that you can turn them into information requirements. So if I want to make a regulation about the width of doors for disabled or for accessibility, then the information requirement is the structural opening and the width of the door jambs. And so one of the things that we've been working on is converting building regulations into information requirements before we test them. But moving on to the actual regulatory requirements, we have three main clauses. The first one is that there must be a latitude and longitude in the model. We must be able to locate our facility to make sure it's in Valencia and not in a neighboring region. Also, there's a general requirement that every object should have a unique name. That's a little bit technical, but if I'm going to report failures, I want to be able to say, detect a failure and say, it's that door that's failed, it's that window that's failed. And so we must have a way of identifying things. So those are the first two clauses or items. In the second clause, we have some clauses about health and well-being and accessibility. First of all, we want to have a requirement for decent-sized windows in the habitable rooms. Yes, and the doors should be wide enough for accessibility reasons. And then two clauses about sustainability. Sorry, I've forgotten where they are. I'm trying to read them. Yes, some remarks about the thermal properties of the external walls. And lastly, a requirement about the windows. And so on. Now, what you can see is that my grandchild has been out with the coloring pencils. and has underlined the key phrases. And she only has 4 coloring pencils. But by using those 4 coloring pencils, we can turn this written document into computer readable rules. So anything in blue is an actual requirement. Anything in green is when it applies. Anything in orange is an exception. And anything in the purple color is a selection of objects or selection of things that you want to affect. And by doing that, we have automatic code compliance checking. I've taken the design that Jörg has developed. I've taken this regulation and I have generated some results. So let's see the next slide. We can generate all sorts of, once we've used our coloring pencils, we can generate all sorts of other nice things. This, for example, is visual programming, and it's stuff that users of Grasshopper and Revit and Dynamo and stuff, they love this stuff. This is generated automatically. So just by having done the coloring, we now start to get other ways of using the information. We can do other things. I can generate the IDS if I need to. We can create interactive checklists so that I can answer questions and answer tick boxes. Nothing to do with BIM. I can sit in the office and answer questions, and I can see if the information I have is matching up with the regulations. Okay? But most importantly, we can do automatic compliance checking, and we can generate a certificate. And in this case, we have generated a certificate, a notification of failure. Okay, I left a few mistakes in just so we would have something to talk about. But on the left-hand side, you can see the clauses, and on the right-hand side, you can see the kinds of objects that are causing issues. And I think, yes, 4 of them are simply that there are some objects that don't have unique names. So that's irritating. But it doesn't matter because they haven't failed any other clauses, so we can ignore that. But we still have 2 doors in this building which are not wide enough. Now, the structural opening is wider than 800 millimeters, but if we deduct the jamb thicknesses, it's not enough room to get Rob in his old age through the door. So we do need to go around this cycle again. That said, I will sit down, and I've given the scheme a conditional approval. As long as they sort out the doors, they can go ahead.
Nick, I'm going to ask you a question before you leave. How is the failure communicated back?
We can generate a BCS file, if you'd like.
Perfect.
That will be shown later. We have indeed BCF.
This is why I should have been at practice.
Yes.
Yeah. So, that's one way of communicating. Or I can print this off and put it in the post. You choose.
The advantage of using BCF, so it can say that that topic is an issue and it's still open, and maybe until they will improve it and send a reapply, and then we can resolve the issue. So now we'll go to next role and role requirements from LCA. Jan Anders.
Yes. Next slide, please. As an LCA expert, I say that we have to calculate the impact of this building, and that we use is the standards, LCA standards, and then we talk about modules, and each module more or less handles about impact and how we handle it, transport it, and mount it. So The first three modules, A1 to A3, is the impact of the material that you have in the object. So when we look at an object in the IFC file, it always, in my way, it depends on one or more materials, but it also handles about mounting them and transport them. So all type of resources that we need to put them in place should be calculated for each resource. So A1 to A3 is the material impact from the cradle to the fabric gate. A4 is the transporting of the material from the gate to the site. And A5 is all the impact of mounting on the site. Then we handle the object's building impact. And that we will repeat for objects or all objects in the model. And what do we need to get this information? Most of the information the LCA calculator has in its back, but we need from the model a good classification so that we need to know what, and a good naming standard so that we know. And if there are calculated, we prefer to get the GT number or some other article numbers so that we can identify and put in the right EPDs or so on for the material. Then we go to the use stage of the and you see B4 and B5 is B4 is no, I dropped it. B2 and B4. B2 is maintenance, and B4 is replacement. Yes. And so on how the object is situated in the model, then I can see if this material would have some replacement or some maintenance. And then we can put up events that says every 3 years I do this, every 20 years I replace a bit of it, and so on. So I can put on a quite good maintenance plan for the building if I want, and calculate. So the B2 and B4 is that. B5 is the renovation, and that we usually don't calculate because we don't know when the renovation should be. And B3 is the repair, and that's all. That should be used in the maintenance plan, so that we don't have to repair. So then we have this, and then we need the information from Mirbek, the energy use and the energy types that you have calculated, and how much energy we use per year, so that we can get in the B6. And in a similar way, we take in the water as well. And the C chapter, or the C there we usually take some standards and put in as a scheme, just to say, based on how much material we have in the building. And then we have the whole plan to do a full LCA calculation. So that there isn't that much, but I need a database, an environmental database of this, and I need the EPDs when I have chosen my materials. And that is the big job to put in. Yeah, but the requirements isn't that much on the model.
Thank you, Anders. And we, of course, we put one space, so we don't want to go deeper, since it's not 100% real project. We just wanted to show that in IFC building later on, you will find the global warming potential indicate as an indication that we did some homework, and that homework will be now shortly presented by our architect. Those requirements that we presented, and now,
Yes,
sorry.
so to open up the secret for Rob, please show the next picture. So dear Rob, that's it. That's it. You got a 25 square meters terrace shaded by a metal roofing. You got wood framed windows and doors. You got a photovoltaic system on a Saddam flat roof. Of course, we have a southwest orientation for the photovoltaics, and we have blinds on the south and west windows, which is very important for Mirbek later. And the most important thing, the pirate flag. I hope you find the situation well. First I posted on the southwest facade, but Mirbek said that's not good, but because it will cast shadows. So I put it on the northwest side, which is on the entrance, which might be good as well. So we have inside of this house, we have about 26 square meters of heated or warm or enclosed living area for you. So 5 square meters more. I explain why 5 square meters more. And well, as far as I calculated, I think it's about 250,000 euros if you want to have it there, excluding the ground floor, the site. So just to have an idea. So what we did was we exported this model as IFC 2x3 and 4.0 to our colleagues that they could calculate with it. For the ground floor, I choose this kind of visualization that shows that there is already some thought about materials inside. So you have a south-orientated living room with large floor-to-ceiling windows. You have a sleeping room with an east-orientated window, so you have sunrise in your room. Thought it might be a nice feature for you. And of course, and this is first time, I'm now about 35 years practicing architect, and first time I planned 2 showers in 1 bathroom, which is very, very special. But and these are the 5 square meters extra. I couldn't do it more densely. But according to the materials we have, I thought it might make sense in this area to have a massive brick walls. They have about 42 centimeters of diameter, so you have a lot of mass that will keep the cooling of the night. We have mineral plaster, white painted mineral plaster outside. We have natural oiled wooden surfaces, especially on the ground floor. And you have this central kitchen block. I hope it's good enough. You see all the furniture doesn't have any material. That's up to you. You will bring on your own stuff. And extra wish was you wanted to harvest the rainwater. and it's the little piece over there, the rainwater tank that collects all the water. If it rains, it will go there. So just one feature I would like to add, because it was not requested, but it's nice to have it. Next picture, please. Because the model was geo-referenced, it was just very easy to export it to Google Earth. And that's your site in Google Earth, or your house in Google Earth. You see the beach situation you choose. And next picture, please. So this would be the view of from your terrace. And you were asking for the jacuzzi. The jacuzzi is just on the left side. So that was my part.
Perfect. I guess 200. How many? 200,000. You said 250,000. You add 1 because of location. The C part. The plot will be, I guess. I mean, the plot will be not payable unless you add some numbers on top. So that's what's great. Yeah. Now about myself, I will skip that part. If you heard all these acronyms we will be discussing, simply don't forget, all that acronyms are our standards and services. Let's make it simple way, in simple language, in a plain language. Will tell you, if you will talk about use cases on UCM, it's a cookbook, and we have some recipes to you. And those recipes coming together with exchange requirements, which is, of course, recipe. Each recipe has ingredients, right? And we need to talk. And since it's this recipe coming from cooks, chef cooks, experts, like domain experts, we need to know the processes. And of course, later on, it will be appreciated or criticized. That was a BCF, by the way, regulatory domain published, soon will publish manual for that purpose, and it's also mentioned there, so you can check it. And of course, our ingredients are in BSTD. We will show you how we mapped ingredient. We picked our stuff for our pizza from the fridge and brought into our IDS, I mean, into our ingredients. So we simply will explain that in simple language. As a context, in the past, we have published an IDM or technical report for BIM and BEM, building energy modeling. It was published together with Jeff Rowlett and Paul Woodward. We worked on different kind of exchange models. We tried to check current situation and what we can improve, especially running 5 expert panels with worldwide experts, including Green Building Certification Institution, USGBC, DGNB, Passive House, and all they were involved. So we got feedback from them, from institution, research institution, and of course, domain experts in general. And it's available under the link below. You can also find it on the buildingSMART International website as a technical report, and you feel free to read it and give a feedback to us. That's most important. Within the report, you will find some exchange models. Exchange models are not exchange requirements yet, but they give you a clear understanding, or rough understanding, what you may have to expect at a certain, let's say, stage. And then, as you can see, also describe who is involved, what you have to deliver, and what is required at the certain use case. It means if you do daylight analysis, what you may have a location, georeference, like Nick already mentioned, also related to regulatory. If I'm running a daylight simulation for Valencia, the results will be not the same if it will be in Rob's home country in the Netherlands. The daylight will be different. So it's the most important to know where we are planning that building. That's most important, and it's possible to map in IFC. And as you can see, we have, starting with a small conceptual analysis, going into deeper and deeper at the end, the stages, including deep energy retrofitting or general energy refurbishment retrofitting cases. What we need there, those are published in exchange models and described in a proper way. In proper way means in human readable. But and there are new standards. At that time we had IDS as a final standard, and they're still coming soon. It means we decided to bring that information into IDS. Providing IDS means you will be able to read machine readable. What's important, if we were thinking about mapping, clear that all that requirements you can map with IFC, with the classifications, and for that reason, it's easiest way to use BSTD. If you put that BSTD and you know that what you require, you can find it in the BSTD as a classification in different dictionaries, previously called domains, and we can match them. Just shortly remind how you create an IDS. There's a simple workflow. It was published many times on the main IDS webpage of buildingSMART International. It's state you capture requirement, you create you use IDS modeler, you create your IDS, you map it with BSTD if it's possible. You don't have to create a copy pasting stuff and waste your time. You use, if possible, use BSTD. And you can, of course, validate IDS itself. You can validate the model later on and export as BCF. So some requirements, what we had for some use cases, just like this one, in previous summit, we have shown you what is useful IDS for on real example is daylight analysis, also related to energy efficiency. And you can see we used our use case management as a place to publish it with IDS. General requirements, I don't want to go deeper, but mention something. We need those requirements that will be later on needed in building energy modeling. I'm lazy engineer, and means I don't want to spend my time improving the model. I want to use time to improve the building and to do my main job, to give a feedback what we should improve to improve in general energy efficiency or energy performance. In most of the cases, you struggle that you import it, or you are not even able to import the building itself. So you have to be sure that the quality is good enough. Everything is clearly defined to be able to import a model into your energy simulation tool. So that's a requirement that you need to use, including the stages, including the properties that you that those may be needed in your simulation. As you can see, we simply stated some requirements that was on top of Roef's requirement. As you can see, the recommendations of exterior design elements, we said that was exactly the same way. Don't put any shading or not shading devices on the south facade, so that it will be not overheated. Big windows, yeah, it's nice, but you need to have overhang on the south facade so that will be able to cool naturally in the way of, you need to have a cross ventilation so that we will reduce energy loss for cooling in the way of not to use active cooling itself. We used on the west facade vertical blinds because usually horizontal, overhang will not help there. So that kind of small things, but they are still requirement that will definitely affect energy efficiency or in general efficiency. So of course, we require the building to be airtight. It should have thermal breach free construction. It has a good envelope requirements. We need to have a spaces that definitely used in energy simulations. And as you can see, we have some areas that should be identified. Though quantity takeoff is also very important for energy efficiency and also to LCA as well. Yes, please.
Is this a non-exhaustive list or this is like the list?
This is a list attached to as an extension to our clients' requirements. It can be extended further. It's just a requirement observation, what was missing and what is important. It can be more stuff. It can be less. And this is not just, this is a requirement for specific project. Those requirements you can extend, you can identify further. And as you can see, this is the next step. Since the client wanted to have net zero energy building and to have very good energy efficient building, so we said, let's make it simply passive house standard. I'm not advertising it, but it's commonly known and used worldwide, including Spain and UK and the Netherlands and coming from Germany, of course. But as you can see, the requirements on the right side, we have a minimum. That was actually a message to our architect. Please provide us the building envelope, including walls and roof and slabs, not less than 0.15 kilowatt per hour per. So you mean U values, and we need the windows properly sealed windows. I mean airtight windows with a good framing. It means insulated framing, and plus it. So in warm climates, it's still okay to have double glaze, but of course, I can also use triple glazed with argon filling and so on. So those requirements that we said we will do that way in our ideas, so that we'll simply check that go through with machine. I mean, with the help of model checkers, we don't go deeper. And there are different kinds of certification. You can also apply LEED, and you can also do the same requirements for LEED certification, BREM, and there are many other certifications. And of course, all those requirements could be also included in the ideas. So it means you can check at least the minimum requirement that you need, but they're not rule sets. Of course, you have to be careful about it. So before Jörg started with his design, there were some recommendations for specific location, and means here for Valencia. As you can see, we said we need good natural ventilation, especially night ventilation and cross ventilation, so that we will minimize ventilation loads, I mean the cooling loads, active ones. We said we will need good overhangs. We need to have maybe some other design tricks to place windows set ways that you can omit overheating and put shading on top and so on. So those requirements you can see in Valencia, they were simply identified. Here's a process map. It's a part of BIM and BEM project. You will reach it also on the link. You don't have to go zoom in, but in general, we went through the process itself, starting and capturing, as you can see my mouse, we started with capturing information at the very beginning, and until below the regulatory body who gave us a certificate. And I will dive in shortly. Here you are. We captured at first, we started with a project requirements, and you can see the IDS logo there. The requirements scope of the project, what Rob wanted from us. We had the local building code from Nick, and everything were added into IDS. We had a chance to talk to architect at the design chart, where we came all together to discuss most important items. And at the next step, we went to, with the help of sustainability consultants, we created our first sustainability concept, let's say, that will be applied into our draft of the building. And as you can see, that draft was also, of course, optimized with IDS later on and put into AR. So it's part of AR and of BIPs. And we had we worked in tandem with an architect, and of course, at the end, that end up in some simple analysis that you can run in any kind of tools just to optimize the performance before you start shaping the building. Already in the phase where you can simply put a shape, you can start some kind of simulations, daylight analysis, and so on. So that is really helpful at that stage. Now we go a little bit deeper. We started with a project simulation, and first of all, I need to have an ideas. Ideas is just as a tool for me, not as a tool, I mean as a requirement in machine readable way. It's a message to an architect be able to read what we exactly need, and that communication went, of course, after all, with the help of BCF, a BIM collaboration format. This is a process map, just show the conceptual design, how you interact between, let's say, sustainability and architecture. As you can see above, there's a lane for architecture and a lane for sustainability below on the green. And those steps that we took over, we coordinated in tandem. It means the optimized way to work in close hand-to-hand with architects. Going deeper, we had a chance to capture information in BSTD. That's really important. We don't have to reinvent the wheel. We simply use information in BSTD. How we did this workflow, we shall try to show you in a live case now. The information that you can use to identify in BSTD is possible. As you can see, it's just an IDS tool, and it shows that I can simply search for any class even from other domain, like here in German domain that we publish for infrastructure. You can simply use that, and you can map the existing property sets and their properties to the class that you may need in your element. This is a comparison between machine readable and the human readable ideas. And you can see human readable ideas is just a bunch of requirements that you have to follow, you should deliver, and the right side is just a schema that in the previous session at the Sustainability Strategy Group also Nick showed in detail. As just an example how you can create your ideas. Then those ideas requirements, as you can see, there is simply we use the Solibri. There are the other tools to validate the requirements, and this is a simple import the first case. The result that you can achieve and simply tag those topics, excuse me, and I will correct myself, topics, as it's just information request or issue. You can tag the element and send the request to architect, please. That's what Jörg mentioned to Rob, why we need to move flag onto to the back, because it would potentially shade your photovoltaic. And you know, photovoltaic is a solar device that especially if you connect them not in parallel but in a series, it will reduce drastically your efficiency of generation. And of course, there's other topics that we created as a viewport. You can see requirements we sent back, and IDS itself for energy efficiency. And you can see there were many topics that we had to clarify, and there was a big task to our architect to work on them. And of course, all that issue was later resolved. So it means majority of them resolved, and we could, of course, had the results that we could work further. And as a result, the most important, the current state, I could, of course, as the first simulation, I was able to, after several IDS checks, we had to improve them. We sent BCF requesting, please change some classes to be, let's say, a specific class that my software needed for energy efficiency or some simulation tool could be able to read. In that case, we can see just a daylight analysis tool, and as you can see, with one click, I was able to see if all rooms meet our requirements for daylight. Yeah, they're red, but we had some issues regarding G values. I mean, that solar transmitter values were not identified, and of course machine didn't get if there's an opaque element or it's a transparent element. So we had in some rooms very dark rooms identified by the, so we could play back the results with a BCF requesting could you please send can you correct the G values of specific window. And of course this is information, as you can see, one room. That was actually also mentioned in the regulatory ideas or a regulatory requirement that all rooms should have 10% minimum fenestration area for whole area in that room. And of course, that's also identification. We have one room. It's here with completely zero results. Working plane room number 2, which is I guess it was a shower room, and it had window without any specific parameters. And of course, machine understood it was actually a pack element, so we don't have any daylight in it. So it was a 0. As you can see, this requirements also we can capture as a result of a simulation. So that went back to other result. I of course imported the energy simulation tool as well, used for PHPP, the passive house plan package was a plugin, and the result was energy balance, as you can see, also shared as a certificate, also shared as a PDF certificate. You can attach as a help of BCF, send it back to architect, send it back to client. This is our results. We are currently under 18 kilowatt per hour per meter square in annum. Means we still have to push harder to achieve passive house standard and so on. Some other requirements we had to meet, but that's requirement I simply put into BCF. So it should, of course, be clearly identified, clearly sent, and send it back to your client and related parties. And plus, it's model-based. Of course, those requirements for later stage, as you can see, this is an improved case in the way of like a case we worked on. There were some still, I would not call them issues. There were some still gaps that we had to clarify. This is IDS on the left side. On the right side, it says, it shows directly the original requirement, as I can see. And on left side, those topics automatically generated in model checker, and in that case, Solabri. We can use, of course, other model validation tools from Akka. There is also model validation, and in general IDS validations, there are also many tools, including XPMIT, and I would recommend that as well to use. So as you can see, second case, we run simulations twice. After architect did some homework, let's say, improvements, we have now suddenly daylight results, which is good to see for the, you see almost 60 looks for shower room. It's okay. I mean, on the north part, it's, you don't have to have a big windows to show our client showering. So we of course we set each requirement for specific room. That can be, by the way, also specified in IFC model later on. If you want to have a built model generated, you can bring that information back into your model before it will be constructed. Then it will be as designed case. And as soon as you reach your as built model, then you will be still having that information. Maybe later on, when you will start using the facility management, and then you can update that again. So That improved case, we reran simulation again. We put that model and we can see results went back. The energy efficiency was improved because we had previously the comparison. If you remember, we didn't have a West Passade. There was a missing window. I can show you the model again. There was a West Passade because that's overheating. The heating load, of course, we don't have heating load for that time, but for a cooling load, since we're in Roef is in summer, our client in summer spending time, if without that element, a shading element that we actually precisely and explicitly requested in IDS to have a IFC shading device, and that was added as well at the later stage. After running simulation, we had the result, improved result of cooling loads. They went better, and in general, the whole improvement as a result. So there was a short introduction of the workflow, and we'll bring you to the live showing just how it looks like, how we do that ideas, how you connect ideas with BSTD. I can just show you some small demonstration. Then we can have general question, but before maybe specific questions. Any feedback, any criticism, positive feedback as well, compliments and so on. And we have half an hour to try out everything. So we don't have any questions. Great. Then let's try. First of all, thank you for our players' role. Without their input, it wouldn't be possible to create these ideas. And of course, this is, I'm really excited to show you some, you can see that, right? Or you have to share my screen again. Okay, this is ideas. I'm trying, since it's an open standard, I'm trying to combine tools. So it means if you create an ideas in one software or platform, you can import it to another one and validate it. Or the same way like you do with processes. Process maps, we use BPMN. The same way you can open them, you can import it the other way. So open standards, that's why buildingSMART is always for open standards, and it's open for also for everyone to join the initiatives. So I opened the first case. There were, of course, some difficulties. You need to identify, by the way, as you can see, we had previously, I mentioned that, we had a previously different version. So now we will update directly with the latest one. It's just a experiment that we would like to have from you. By the way, you can help us to identify maybe some additional requirements that we forgot to mention. Regarding building, yeah, as you can see, all those requirements on the left side, they are simply they are items or elements that we need to run. They might be more, where it's not full schema. Especially, I'm not talking about IFC 4.3. There are, of course, stuff from infrastructure domain. I forgot to mention, this ideas covers only building so far, building related elements, and of course some of them applicable to infrastructure, but as a facility we may lack bridges or so on. So the main focus is a building energy efficiency or building energy modeling. We're not talking about facility energy efficiency. Okay, let's go to some details, and we have even some requirements. As you can see, you can specify, you can be strict even with the requirements. So we said we don't want to have any building element proxies because that will not help me in my building energy modeling. So please identify what is it exactly. If it's transformer, or if it's heat pump, please identify it. Otherwise, that will be lost along the way. It will not be imported. That's important. We identify no building element proxies. Why it's important? At the end, before even I will spend my time trying to improve the building or trying to import a model and wondering why I don't have suddenly my IFC, my heat pump. What that will be most important thing in some cases for energy calculations. That's important to keep in mind. That's just a requirement that we thought maybe will be useful for all energy simulation experts. So I will go back to the building, and we thought in the building we have so many requirements, and of course they must be, you can identify by yourself. As you can see, building has, the building itself should meet with IFC class, IFC building. It may have common properties, it may have base quantities, it may have specific properties. I guess here, as you can see, global warming. You remember the requirement given by Jan Anders? That requirement came through BSTD. I didn't put any single, I didn't use a copy paste, but used the linking with a BSTD. And that's how you do that in BSTD. The information will be caught from BSTD. It means at the end, you can also, if your beam authoring tool is also able to map it, some of them does. So you can simply attach that information into your BSTD. Yes, it does. Or Nick, you don't agree with that? Have a comment?
A lot of requirements.
Yeah, I know. Some are mandatory in some cases. Of course, there are really many requirements, but still we need to refine. It's still in progress. It's just showing you some intermediate results. They will be fine-tuning as well. Okay. At the end, what we do, we add additional requirements also from BSTE in the simple way. Let's say just an experiment for you. Anything that you would like to add from BSTD? Just energy efficiency, anything that might be interesting for you for building. Let's say water efficiency or whatever. What about water? What we have about water? So you can see there are already classes. You can identify them, and you will choose a related property set. Just of course, it's not the way you do, but if you press some, you can find the related property and add into your ideas. That's how I did. I don't have to reinvent the wheel. That's the easiest way. Okay, then that was a result. We can have, like I said, we can have XML, like in a machine readable way. I'll show you. I don't want to repeat it again. And I'll open the model again and just try to show you the real simulation, how we managed to run that case. So let me open the first case. This is a building. I think it was not yet improved case. Yeah, it was the original case. And in the original case, of course, we had to do some checkings. I will save you time. I guess you're all hungry now. And as you can see, there's normal checking results. There are some topics that we had to deal with. There's classical that we can use a rule set. And second, this is a BIM and BAM results from requirements. As you can see, there are some missing items or important stuff that we had to do. And thanks, Jörg, we have resolved those topics and issues, whatever we had information. This is just an example. Like I said, we moved the flag, or we had we moved the photovoltaics on the other side. I showed the ideal location for photovoltaics because afternoon sun from west, as you can see here, will be not ideal for photovoltaics. It will be all shaded. We need the maximum efficiency, energy efficiency. It's not energy efficiency, it's just an efficiency, because energy efficiency is a passive that belongs to building. But still, we can communicate results. And as you can see, those results are mentioned. Nick here, thanks to his results, we had a chance to directly provide a certificate This is, of course, generated by Nick. His results were attached back to as a certificate in BitCF, sent back to the client, an architect, first of all, has an homework to do, and as a issue, in that case, I would call it issue. We need to resolve many questions and requests from the building authority. The same way rule set issues, as you can see, there was some, I would call, and let me pick maybe one specific one, let's say, let's check one. I think it was about values of shading or missing properties. Of course, there are many, but still we can identify them. They would automatically generate. I didn't create any item here. It was sent back to with the help of ideas. So it's automatic generation of issues. It of course helps to identify where we currently have problems, where we have to, what should be improved, and of course that's an advantage of having machine readable requirements. So I think that was a part where we run that requirements, and I can open you the latest improved case. Let me close this one quickly. So this is, I guess, our improved case. By the way, you have to walk a little bit towards the sea. So we have now also a shading device on that was missing part, and as you can see, many things were improved. The improvement, of course, coming was feedback from architect that the results or this topic were no more open but closed and resolved. So it means if we use OpenCDE and a common data environment to exchange BCF, then you have directly those tickets being directly updated. For this experiment, we skip that part. So we can go to the communication part. As you can see, the results, I simply used BCF to simply send back our like say energy simulation certificate and so on. So energy balance, and of course there are some others. The most precise I will go through more other things. So it means I go to the ideas. By the way, the main message, ideas is just the not scaffolding. It's how are they called? Formwork. It means before you pour concrete, you have your forms, right? But how it look like, you define. You are a domain expert. If you will use a basis ideas as a basis, you can identify those requirements and put those may requirements to must requirements, to change them as a must, or exclude something, include some additional stuff, include values. By the way, you can say I need to have a building with properties, but if you don't identify the values, it will be no matter what property values will be. If it's in general included, yes. If it's true or false in some Boolean cases, it doesn't matter. But if you say I need load-bearing wall or is external common property from walls, if in the building suddenly the outside wall is internal, I mean, as a value is external, is a value false, then we'll have directly issue there. I mean, topic shown in the model checking. So that's how we do. And of course, if you do the model successfully, you can import model without any issues. As you can see, there is a results here. I don't even spend 5 minutes simply importing. It helped me to run simulation and spend them mainly on my results, saying, okay, let's improve. Let's put here some shading devices. Let's put maybe a solar roof, or they call it skylight on top, or solar tube to improve rooms so that we have very dark places. So that's how we work. That's how we play ping pong with the help of BCF and with the help of IDS and BSDD. All this information, like OpenBIM workflow, works, and that was the objective of this session. I think, with demonstrating this example demo, we reached our goal. I think the client is happy and would definitely order that building from our architect, and we will see someone. Maybe we can visit you next time in Valencia in real. So at that point, I think we reached to the final, to the agenda point where we had a discussion and questions. And so far, we can go to the main scenario. We have it somewhere here. And maybe some questions as a refresh. We went through client requirements. If you have requirements, why identified that or we describe it that way, you can take a chance and ask. We have requirements from building authority. We have requirements from LCA. We have requirements from building energy modeling. And you can also ask questions why architect decided to do that way and not other way. So it's a general question, or maybe technical questions. Feel free to ask.
Question? And run back there. Anything online, Sheila, right now?
Yes, we have. Is that working?
And first, let's ask them.
Oh, sorry, go ahead.
Go ahead. Okay, thank you. First of all, congratulations. And second one is about the thermal load. How can I calculate it? Because it's some kind of a subjective, because we need to consider in the home appliance, the use of home appliance. Sometimes it's only alphanumerical data. And sometimes in Energy Plus, I used to put in a parameter, but it's possible to model the appliance and having the use of this kind of thing. And the use is thermal load about the use, the occupancy of the people. Do you have some feature or some kind of a situation that you can put it in the requirements and check it check the thermal load and having some kind of a number of it?
Yes, it's of course you can do that way. You can, of course, the first there is two different ideas here. I mean, the first ideas we're talking about is the quality of the model that we will be using for energy simulation. It means I need to actually some things should be may. It means I don't expect that Jörg, in our case architect, will provide me thermal load of the building. That will be actually nonsense, because he is sending it to me to run the simulation. I will be able to send it back. But the prerequisite of thermal load for that will be a building itself, or if you have specific thermal load for the room or for some object, then you will identify related to that. Let's say we use zones, because what is the conditional zones, and we use, of course, IFC spaces for that. I mean, I have rooms. If let's say IFC, the room here, let's say 3A should have these values, and it will come. Their requirements actually will come also from MEP engineer, mechanical, electrical. Sorry.
You can show it
Yeah.
There are some values already entered by the architect.
Yes.
For example, how many people are living in those groups? That's one feature we had to enter. We have the values for wall, insulation, lambda value.
Lambda values is U values is mainly for the whole component. Lambda values is for some parts of the components. It means layers. Let's say if we have lambda values for insulation, and the BIM Outer tool will be able to calculate what's the whole values of U values of a whole wall, let's say layers. I mean, the layer itself, the lambda value is just component related, and U value is for whole assembly. Let's say wall has U values of 0.15. It means we will have to use, to reach that, we have to use, let's say, insulation mineral wool of 0.034, so that with a thickness of 20 centimeters, just an example. And additionally, there will be a concrete wall and so on. So that would be, and the whole thing will be calculated. That's just a thermal loads of component, but not the whole room. Room will be calculated later on in, of course, in the IFC space. It will be attached to IFC space, and that comes through the simulation results. Of course, that we don't expect from Architect. Otherwise, we don't have to do anything there later on. Plus, IFC space, and if you go to BSTD, IFC space has many property sets related to that. If you have, there are loads that for thermal, for cooling, heating as well. Plus, good that Jörg, you mentioned about number of occupants. That's important for my calculation. I know how many people there, then I will be able to know if we need to put additional ventilation or so many. Like if we say we have 10 meters square and we have 30 person, then that will be tough. We need to have an active ventilation.
Okay, you want, we've got a question
Now,
online? Sheila can read it.
Yep, sure. So Jose Santos makes a comment that the presentation starts with LCA analysis, but after only energy analysis was shown, and also regarding the other areas of LCA analysis, is it developed nowadays in BIM? Don't you read it?
I'm just wondering, we haven't have any LCA analysis shown. We just mentioned that we will run, and of course, it's a prerequisite for the building itself, prerequisite for LCA analysis. Of course, we need to, first of all, we need to run building energy analysis to, as Jan Anders mentioned. First, I need to run my simulation so that he will be able to put that as an input into the next simulation. We have a comment from Nick.
Yeah, earlier today, we presented the sustainability information requirements, which cover all the aspects of LCA. And we specifically said that we didn't cover the energy analysis of buildings, because that's the scope of the IDS we've been looking at here. But the sustainability information requirements say what information should be held in the facility model, and what information should be held against each of the products or materials or types, and what information should be held in the declarations. So IDS is a vehicle to ensure that those purposes that we have for the model are actually supported by the information we're delivering. So yes, we're talking about LCA here as an outcome, or part of which is using the outcomes from the energy analysis.
I have a question, because I think you mentioned that in one of your answers that the U value is calculated in the BIM model. But my question is, what about transmission resistance? I'm not a big energy expert, but when I did it, I saw, for example, when I come from Revit, okay, it takes the lambda values of the layers, but does it know, the BIM model, that it's next to air on the outside, or does it know that it's in maybe under the ground?
Yes.
So energy experts should have notion of what that U value of that comes out of Revit and exported to IC is, because it might not be totally correct.
Yeah, absolutely. Then it comes. Thank you for exactly mentioning something that we forgot to not to require. The building model. When we you remember, Jörg, we discussing how you should there were some recommendations that I mentioned to mention. We needed model with space boundaries, and especially with second level space boundaries. That's also an IFC covered. Of course, there are not many software that supports it. But if you work with Revit or ArchiCAD and other BIM authoring tools, you are able to export that information. That's important. In some building energy simulation tools, can name them, don't have to, but there is a must. This is a must requirement. If they are missing, I mean, second level space boundaries, you will not be able to import it. So it means there will be a warning. Your model misses second level space boundaries. Even the first level space boundaries are not enough. If the second level space boundary is not there, forget it. That was a really must requirement for me. Second level space boundaries means you need to also have a spaces as well in general. If you send me a model with just without spaces, I will not be able to run any simulation. So good that you brought that. And there is currently a discussion about the space boundary, second level space boundary, in general space boundaries on BSI forum. There is a forum called forums.buildingsmart.org. There is a review of some issues related to building domain, and we called it. There was some suggestions from some experts. We discussed also the same thing. We discussed also in IDM, BIM and BAM, because a very important aspect to cover. We also discussed in the forum that suggested some improvements. I can name experts. Elizabeth Eckstedt, she's come from Fraunhofer Institute, and she proposed some additions or some improvements that we can discuss, because there are some issues that we need to work on. And of course, Jeffrey Ouellette also mentioned in the past as well. Yeah, Jeffrey Ouellette as well. Sorry?
Nothing, I'm just kidding.
Yeah, that's great. That's great that you mentioned about it. It's also a message to software vendors. I mean, for building energy modeling software vendors, and some of them or majority implemented IFC2 schema. Some of them support IFC4. That's why we require, by the way, to export nowadays two models. I mean, two versions of IFC4 and IFC2 because if we say everywhere we need only IFC4, we will not be able to run anything. So that's of course sad sometimes, but we have to be precise with our requirements in ideas, by the way.
Any other questions? There's no other questions online,
So
yeah.
So this is just to validate if what I think is correct, but as I understood, you use the space model to do the energy analysis. So that means, because I've seen you use IDS, IDS is mainly used for checking alphanumerical data.
Yeah.
So there is no really geometrical requirements, like level of how detailed geometry should be. That's not needed for this use case, if I understand correct.
No, we need to have a geometry as well. How you would?
Yeah, the spaces are calculated on base of the geometry, but pure to export from IFC, do you need just the spaces and all the information connected to that space, or do you need also a lot of other geometry?
Clear, all other geometries as well. If we say we need walls, of course, it has geometry. We need base quantities, especially base quantities from geometry.
Okay, but for me, the
base quantities,
are alphanumerical information again exported.
It's still it's still alphanumeric, but it's still the geometry also plays a major role. Without geometry, I will not be able to see if it's big enough to place some equipment, and also if I know some software are able to calculate the volume just for air tightness cases. I know the air tightness is also important. So it means I know the geometry of the room. So I will definitely be able to calculate the volume from that.
Okay, but so you do not need detailed geometry.
Sorry?
You do not need detailed geometry. Because when you say you have requirements for this use case, you require normally alphanumerical information, documentation, following the level of information, and geometry. And my question is, but I didn't really see this in this presentation, is how do you require, or what specification do you have for geometry?
I need to check it as well. But in general, there is a part of, if you use MVDs for exporting, then there'll be anyways requirements for geometry. Usually in IFC4 reference view or IFC2x3 coordination view, this is a classical, you will be exporting model with geometry. And of course, if it's enough for your simulation, we need to specify more. But in general, I don't think that if you have to go deeper, so deeper into the detail, telling I need specific geometry, but that will be out of scope.
So this model has been LOD 300 something about.
Sorry?
This model had LOD 300 about.
Yeah.
So could you work with less?
Yes.
Like that?
Yeah, I mean, a minimum requirement. If you say I need, you remember the stuff that I required. I need as a minimum requirement, I need at least IFC spaces. That's minimum. If I don't have IFC spaces, I will not be able to export what? Second layer space boundaries, and I will need to have a building envelope in general for spaces. Without that, I will not be able to run any. It doesn't make any sense.
So that means chamfers on all of the stuff.
Yeah, sure. That's yeah. So it depends on By the way, it depends on software and software type. If I say I need for passive house simulation, column in inner part plays really a not major role, because yes, it will still play a role when we will be calculating TFA, treated floor area. It will say, yes, more than this, we need to have that into account. But in general, I'm focusing, of course, on the volume of the room. I'm focusing on the building components, outside especially, building envelope components. If they're, what are they? Lambda values for some components, and then I will calculate further. But without that minimum, a building envelope and spaces, I will not run any simulation. I will not be able to do that. So that's a minimum requirement. Especially minimum requirement for daylight, if the previous use case I showed you. That's what makes sense daylight. I need openings. If you don't have an opening, why you have to run a simulation for daylight analysis? Yeah.
Anything else? There's a couple minutes.
Yeah. Now.
Yeah.
Sure. Two of them. You have two questions.
Two of them. 2 minutes to get to lunch early, unless there's a quick question.
Questions?
Anything?
No, the is that you cannot be in Spain. I know that's
Sorry?
you can't be so close to the AC.
Yes, that's exactly it. Yeah. You mean on the sea? What did?
Yeah.
Okay. Because of flood, or what was the reason? Okay. Yeah. Sea level. Yeah, that's regulation. Absolutely.
Rob's got a lot of money. He can probably just.
So it means architect plays major role. Everything, like in Germany. Yeah, that's exactly. Great.
Right.
We think if we don't
Thanks,
have
everyone.
any other questions, thank you so much for joining us. If you have any other questions, feel free to reach us. Really glad. We will publish somewhere use case on ECM with ideas attached. But the ideas will be, like I said, this former. The deeper you will